Welcome everyone to our module 0. This is called module 0 for a reason because we have not yet started diving into the content of the course itself. But this module is just for you to brush up your C++. As you know that this section of data structure is in C++ and not in Java. So I have put together this introductory module, module 0, to allow you to just be aware of some of the integral concepts of C++, because you will be eventually doing your assignments, project, everything in C++ in this course. So it's very important that you are well versed with the language. So let me remind you that this is not a course where you come to learn C++, but this is a course where you are assumed to know C++ and you are assumed to be interested in learning data structures using C++ as your basic or as your base language. So let's dive in. So basically, we will be having it's you are required to, if you think that some of these concepts are not that clear to you, you know C++, but you don't know up to the extent to understand these concepts well, then if some of the terms in our discussion today is going to be Greek and Latin to you, assuming that I don't know Greek and Latin, so something like that, something that you don't know at all, then you are expected to read the concept from the textbook. So let me start with giving you the reading assignment or from where you can read more about that, because we are not going to dive into like extreme intricate details because of the time restrictions. We are just going to revise very quickly and pass through different concepts in a very brief manner in this module. But then if you think you need to know more details about something, then referring to textbooks is the best. Even if you think that you know C++, but still I would recommend to go through these chapters in the textbook, because having a strong background concept of these things will never hurt you. And it is indeed going to help you throughout the course. So it's something like your base construction of a building, and you want that to be strong, right? So reading the textbook chapters is something that's mandatory, and you got to make time for that. To make your job easy, I have made a list of things that you can read. So we will be following the Ford and Top textbook, as you see in our syllabus, as we discussed in the introductory launch section before this module 0. We will be following mainly two textbooks, one by Ford and Top and other by Corman. So in this specifically related to C++, we will be dealing with chapters from Ford and Top. So I made a list of chapters that you can read from Ford and Top textbook. We will be covering different concepts like classes. For classes, you can read chapter 1, number 1, from Ford and Top. All the chapters are from Ford and Top. That's what we'll be referring to. For vectors and containers, you can read chapter number 4, again from Ford and Top. For operator overloading or on the concept of overloading, you can read chapter, it's covered partially inside chapter 2. Specifically, it's in the section 2.4. It's towards the end of chapter 2. So you can read that. Pointers is a very important topic. To be able to program in C++ or C, you got to have a clear concept of pointers in your head. And if you are confused about what pointers do or how they are used, then it might make your world of programming in C++ a nightmare. So having a basic and clarity in your understanding about pointers is very important. We will be discussing with some examples of how things can go wrong, or something that will help you to develop understanding with the pieces of snippets of code for pointers. But to have in-depth detail or to read more about pointers, I would refer you to read chapter number 5 in Ford and Top. Also, chapter number 5 touches some of the concepts of copy constructor. There is no specific chapter on copy constructor because it's a very small topic, but constructors are important, and having a good understanding of that is also important. I think chapter number 5 touches to some of the examples that does use constructor too. So I think when you reach chapter number 5, you'll be able to have clear understanding of pointers as well as constructors. Also, there are some another, so constructors is, as I said, there is no specific chapter in Ford and Top. It would be covered and it is covered in different examples in different chapters. So look on the basic definitions of constructor, just a Google search is good enough to look up that. And then once you know that, okay, this is something called copy constructor or the constructor, we'll also touch to that in our today's module in this module 0. But then you can, when you're looking at different examples in other topics, you can always look for, okay, is this a constructor? Is this a copy constructor or something like that? So it's something that you have to like dig through yourself, but it's not a very big topic, so it's easy one. About iterators, it's covered in list and iterators topic in Ford and Top. That's covered within chapter 6. So these are your reading assignment. Again, all these chapters are from Ford and Top textbook. And once you do this reading assignment, you should be well versed with C++. So let's jump in and let's start revising each of these concepts. Again, every module of this course is going to have a to-do list on your Canvas. This is just a snippet of that to-do list for module 0. It very finely lists the items that you are expected to complete in order to complete this module. And in sequence, we have one after the other module. So the next module will be module 1 and module 2, and then so on and so forth. So it's expected that by the time we jump into the second module, into the next module, you are done with all the to-do items in the prior module. These to-do items are not optional. They are mandatory. So what does the module 0 to-do item are? First is you should be able to access STL document that's accessible via Canvas. If you look into the student resources, then there are instructions on how to access that. So you should be able to do that, follow that, and you should be able to access that. Because we will be using STL into our programs, it makes your assignments easy because there are already that's a library that has pre-coded header files. You just need to include that header files. And throughout this course, we will be looking at things of how to use that header file. So you don't have to code something from scratch. Rather, there is a library of resources available to you. Just tap into that and you should know how to use that. So accessing STL document standard template library is very important because that's that resource globe that's available to you. So you should be able to access that. As we just discussed, these are your reading assignments from the textbook. You should complete this. Again, it's not optional, it's mandatory. So you should complete this. And then you need to go through the project style documentation guideline. Let me just amend that it's not just for project, but it's applied to anywhere, anything that you code for. So it's basically kind of coding style and documentation guideline. Anything that you would submit, anything that you would code, it needs to be done in a way following the guidelines available in this document. This document is again available on Canvas. And the last and most important thing, there is going to be a quiz for the content of this module. So you better do all your to-dos before attempting this quiz. And this quiz is again going to be on Canvas. You can try to each question of the quiz. There is no limit to how many attempts you are allowed to that, because the goal is for you to learn. So if you get it wrong for the first time, you'll get to know, and then you can again attempt that question until you get it right. That's why if you get it wrong, don't be upset. Just go back to the concept, revise things from the textbook, from our today's module lecture, look at that again. This will be available online for you to refer whenever you want. So look at that and then get back to the quiz questions again to get it right. So getting it right is important. Only if you understand the concepts, you'll get them right. But do complete your quiz on time before the end of this module. Okay, so then with all the expectations set right up front, very clearly, let's jump into the actual technical details of the content. Let's start with the classes. Can somebody say what is classes in C++? Can somebody think of it by themselves and formulate the concept of classes in their mind? You must have seen classes, the concept of classes also in your programming 1 and programming 2 um, um, classes before you took this data structure class. If you are with FIU since beginning, if you have transferred from other universities like Miami-Dade to FIU, then I'm not sure what courses you have taken there in your previous undergrad classes. But then somewhere, if you would have touched the concept of classes, that remains same for even for C++. Basically, classes is a concept where we want to group the objects that have similar nature into one package. And then once we create this package, we declare like we have objects from this classes, and then we use the whatever we defined inside this package again and again. So let's give in real life, let's try to relate it with a real life example, right? So all of you in our class, in our this COP 3530 class, each one of you is a different student. You have different background, you have different understanding, and basically each one of you are personally different from each other. But still you have something in common. That is, you all are here to learn more about data structures, correct? So that's something that common characteristic is something that grouped you into a same class. That's exactly what we want to do with classes in programming or classes in C++. We have different objects, the objects that have common characteristics, we want to group them together as members of a same class. So classes in C++ can contain two main items within them. Can anybody recall what are these two main items? I'll give you a minute, actually 30 seconds to recall. C++ classes can contain, first is data items, and second, it can contain functions. Data items are variables that you always use in your any program, right? Now, I think we do not need to go into what's the role of variables in the program, and you all are well versed with that. That's what I'm expecting. And even functions. I mean, I don't think we need to go to that one more layer down to nail down the definition of functions and what they are. By this time, you should be well aware of, okay, what are functions in programming? And given that level of your knowledge, what C++ classes contains is functions and data items such as variables. For example, let's look at this class time24. So here we see that we have two data items, right? Hours and minutes. These both are data items. And we have two functions, even this is a data item. And we have two functions, which is operation at time, and we have operation duration. So these two are functions in this class. What we want this class to do is take these variables of hours and minutes and do something for us, right? So for example, this add time function, it's taking an argument 50 as its input. This 50 is a time. So what we are doing is it has some ongoing time, which can be the clock time of your system. And what we are saying it is add this much time to that, whatever you have. So what we are seeing it as, if it's 9:30 a.m., then we are asking it to add. So if we consider that our clock system is from 0 to 23 hours, and in any clock system, we always have 60 minutes, right? 0 to 59. So then in that case, with this operation at time, what we want to do is add 50 to this 9:30. Adding that, now come on, common sense, you know that 9:30 plus 50 minutes will give you 10:20. That will be your result time, but this is what we want that function to do. We have this another function called duration, where we are giving two time, right? Where we are saying, so if this is the wall time or the clock time of the system at that time, then we are giving it an input of t, where t is just this, where we didn't have space to write, but let's say that t is 16 hours, 15 minutes. Then what we are saying it is that find the duration between this time t and the clock time. So what it's doing is t minus this item subtracted by this item, right? So that's equal to the duration between these two times is nothing but 1 hour, 30 minutes. So this is the function in which we put two data members, hours and minutes, and we put this is the class in which we put two data members, hours and minutes, and two functions, add time and duration. In the world of coding, in the world of C++ programming, how we use class is the class declaration is we need to use the name class, and then we give our class name. Class name can be anything that you like. In this case, we can give a class name of time 24, right? That was our class name, our class name previously in the example that we discussed over here. And then what are these things? Can anybody recall what are those things? What are they called? They are your visibility labels. If you have thought that, then congratulations, you are correct. Are we missing any visibility label? Is there anything else? Again, as I said, that you are expected to know C++, so this is just a revision and you're trying to recall something that you already know. So that's why I'll be asking some questions like this, and you are expected to recall things from what you know. We have public visibility label, we have private visibility label. Do we have anything else in C++? If you are thinking protected, then you are correct. So we have public visibility label, private visibility label, and we have one more, which is protected. It's very easy to understand the concept of each of this and differentiation between these visibility labels. As you know, as the name says public, the content within that, within whatever you have within this visibility label, all the data items and the functions that you declare within declare as public members of the class, those are visible to everything else in the class. So if you have an object, you can access all these data items and all these functions from object in the globe of whole program. Then you have private data members, and you have private private member functions. These private data members and private member functions, they have the scope of their visibility is only limited to the member functions. So if you are accessing a data item, if you want to access a data item that's declared here within the private label, then you need to ensure that those data items are accessed from the functions only of this class. So those functions could be described as a public over here, and then you can access this data item from this calling from this function. So the function needs to be a member function in order to access something that's declared as private. Protected, the concept of protected is nothing but you can access things. It's similar to private, but it's a bit more liberal compared to private. So not only the functions of this class, no, so not only the member functions of this class can access things that are labeled as protected, but also the classes that are inherited from this class can access the things that are labeled as protected. Again, if inherited is a new word or is something that does not ring the bell of a clear concept in your mind, go back to the textbook. ForeignTop has a short or long, I don't remember that exactly, but it has a clear explanation of inheritance and abstraction. You can refer to that chapter and read about inheritance and abstraction in object-oriented language. So logically, if you think, public is something like you have a phone and everybody knows your password. Okay, so that's something like a public. Private is something like you have a phone and nobody on this earth knows your password apart from you. It's only you and you who can unlock this phone. Protected is something like, hey, you have a phone, you know the password, maybe your girlfriend or a boyfriend also knows this password, right? So then there is a limited set of people who knows this password, or maybe your parents know this password, maybe your kids know this password, so something like that. But not everybody knows this password. So that's the difference between public, private, and protected. Very easy to remember. Just remember your phone and remember who knows its password. So if we look at the code for class time 24, I have put together an example over here where we have some data items and some member functions under the public label, and we have some data items and some member functions under the private label. So remember what I said, what I just explained about what how to access the data members and member functions of things that are labeled as private versus how we can access the data members and member functions of things that are labeled as public. Recalling that, what do you think will be answering these two blanks? So if the label is public, then these data items and member functions are accessible to what of time 24 class. So what is the accessibility permission for public? I think most of you should get this right, okay? Because we already talked about that just like a minute back. So if it's labeled as public, then it's accessible to any object or objects inside or outside of class 24, time 24. So public says it's accessible to any object. Doesn't matter if it's inside or outside the scope of class, whatever class we are dealing with. So here we are dealing with class time 24. If it's private, then it's accessible to only the member functions of the class. So the class is time 24 here. So if it's private, it's accessible to only member functions. Of a given class, of class time 24. Okay, moving forward. We have another nice keywords or the concepts to recall. So given again some class, like for example, class time 24 over here, what is the group of functions and data within the same, like grouping the concept of grouping the functions and the data members within the same class called in any object-oriented language or object-oriented programming. This concept that a class has data items and a class also has member functions is called something. What is that? Encapsulation, correct. Again, if you don't know what is encapsulation at all, or if you don't understand by this line, then please read in the textbook. Encapsulate or encapsulation. That's the concept of grouping the data members and member functions both into the same, under the roof of that same class, grouping things that have similar characteristics in one package. What is the concept of hiding the implementation details from the user of a class called? So we do like these details about what is public, what is private, what is protected, how these things can be used, those things the end user of the program doesn't need to be much aware of the in-depth details about this. The user is just bothered of, okay, how to take advantage of the things that's served by this package. So this package is class and the user doesn't need to be bothered of integrate details of how this package is formed or how the class is formed. What is that concept of hiding the information details from user known as? Again, this is a concept of object-oriented programming languages. That is also true for C++, but not only for C++, it's applied in Java, in any other program, object-oriented programming. Information hiding. This concept is called information hiding, and C++ also uses the same concept of information hiding. Okay, so then let's look at an example of a class where here in this example, definitely you will have your libraries to include, your namespace to include. We are using std namespace. And then as you see that we have two classes over here, class A and class B. Particularly, we are looking at some of the concept that deals with multiple classes in the same program. So let's see that you have two classes in the same program, class A and class B. And what we are doing inside this class is we have no private label. We just have a public label in both the class. In both these public label has this public function, which is void print. And inside void print, we are just printing hello from whichever class it is. So from class A, we are printing hello from class A. From class B, we are printing hello from class B. This way of defining the function in the class itself is inline functions, right? Again, this should ring a bell, the word inline functions. If not, please read about it more in the textbook. I'm just writing short form for the function. So this is inline function, but you cannot write all the functions as inline. And that's why we have scope resolution operator, which we use by this symbol. This should ring bell. So most of the program, we just declare things within the class, but we define those functions by using the scope resolution operator later outside after closing the class. But if it's just one line, then we can use it as inline function. As you see over here, we are defining what the function print does within the class itself. So that's an example of inline function. What we are doing here in the main is we are declaring an object one, obj1 of class A. Then we are declaring object 2 of class B. And after that, after we have objects for both of our classes, so to use the things or the functionalities within the class, you have to have an object in your main function for that. So once we have that handle of objects for both of our class, then we call this function print of both of these class. So what do you think when you run this program? What do you think it would print? So a couple of questions over here. If you have not triggered this question by yourself, then let me trigger them to you. So here we have two classes in the same program that has the same name, that has a member function with exactly the same name, print. First, is this allowed? Or is this some kind of violation that will result into some kind of error when you execute? Second, we also have two objects over here, right? Two different objects. And these two different objects are calling the same function. So whatever output you get, will it be correct? What you expect? So what you expect here is hello from A and then hello from B, two lines as your output. But because we are having two different objects calling the same function, will it be able to go back and trace to what we want? And will the output be what we expect, or will it be something different from what we expect? Like, for example, just hello from A, or hello from B, hello from B. Or for somebody who is even one level advanced in thinking your horses of mind, might be thinking that here you have two objects that are different, obj1 and obj2. They are two different names. Let's see what happens if you have both the objects of same name. For example, A obj and B obj. If you have something like this, rather than differentiation of 1 and 2, is that allowed? This is the level of details that I was talking about, that you should be conceptually clear in sense of how C++ programming works. If these things are not clear to you, well, you got to do there some intensive reading and understanding to ramp up to the speed. Okay, let's go ahead and understand this, how these things work, because no answer is good to just memorize. And if you understand everything, literally, you don't need to memorize most of the thing. So understanding is something that will last with you longer than just memorizing things. You would forget the things that you memorize in next 10 days, next 1 month, depending upon memory, but definitely in next 1 year. But if you understand something, then you can always look back to that understanding and you wouldn't go wrong with understanding the concept. So let's understand this. Let's see that, let's visualize that this is your memory. Not your memory, but your system's memory or the computer's memory. Now in this memory, we have two classes, right, for this program. That's class A and class B. Both these classes have a function called print within them. And then we have two objects, at least to the printed program, for our initial first case. We have object 1 that points to class A, and we have object 2 that points to class B. So to answer our first question, is this allowed to have two different classes in a same program to have member functions of the same name? Is it allowed? Yes, it's allowed. Why? Because as you see over here in this memory, the different classes like class A and class B is located on different actual space. So the memory addresses that corresponds to store this class A is different from the memory addresses that corresponds to store class B. And that's why it doesn't matter if the functions within this memory addresses, they have same name, because in spite of them having same name, they have different addresses. And that's what it matters to us. If they have different addresses, then whatever different we do within these functions, the only one thing difference that we do is here we print hello from A, and then second one we print hello from B. But you might be doing more different things in a more realistic example. This is just a sample for you to understand. But that's okay, because this memory addresses are different. You can do anything that's different, and you will be able to trace back to that different things using this different objects. So object 1 and object 2. So if you run this program, then it will print hello from A, and then it will print hello from B. But if we have something like this, something like having, let's see if I can, nope. Okay, let's just continue with this, sorry. So let's say that if we have two objects, those are of same name with something like this I showed over here, then this is a violation. Why? Because the scope of the member function is within the class, right? But the scope of the objects is your whole memory. So if you have two objects that are of same name, That means they are allocated some same memory space in your memory. And because it's the single address space that both of these refers to, they cannot do different things. They need to do one thing because it's only same space that they got. So if we say object one, do one thing, if we have another object pointing to the same space, then that, in spite of saying it or not, it has automatically done that because that address space in the memory is already changed. And that's the reason, though different classes in a program can have member functions of same name but doing different activities, but the objects of different classes cannot have same name. This is very important to understand. And many people do mistakes in this concept. And that's the whole reason I wanted to give you an example and then explain the concept behind that example and whys behind that example. Okay. So proceeding further, let's see another concept of templates. Now, many of you would be aware of using templates with functions because it's more common. And we also have in C++, your classes can also use templates. So as you might already be aware, the purpose of template is to give you independence from a specific data type. So the purpose of template is having the usability of one thing across different data types. Now, you know that we have different data types like int, double, char, string. All these are various data types that we have. And depending upon what we want to do, we want to use different data types. So sometimes if the input is integers, 10 plus 2, then your operation is, or whatever you are returning, that item is also an int, which is 12. But if the input is floats or double, something like 1.986 plus 3.512, then your result also is a float, right? So if you want this addition function that you write to be applicable to both int and floats, or int and double and floats, then you would declare that, define and declare that function using template. In the same way, even for classes, if you want the things that you're doing within the class to be applicable across multiple data types, then you need to use templates for that. So how do we use templates for a class? Here is a very simple example for that. So there are some rules of using templates. You need to use this keyword template, type name T. This, whatever the type name that you give over here, I've given here T. We will use that. Think of that as your data type. Now T becomes your data type. And usually what you would do is when you declare something, you'll have int a comma b comma c comma x y z, something like that, right? Here, because instead of int, t is our data type, so we are having t first comma second. Then usually, like, this is the common, we have public label, and you have add, what is this? Can anybody recognize what this add empty bracket, empty curly bracket is? What do we call it in C++? It is a default constructor. As I said, constructor as a topic there is no separate chapter in Top textbook, but it comes binded here and there in different examples. So this is what I was talking about. The add over here is a default constructor, and this add over here is a parameterized constructor. So in this parameterized constructor, we are passing two input arguments, TA, TB. Again, use whatever you have as your type name as your data type. And then we are doing something in this. We are saying, okay, first equals to A, second equals to this. And finally, we have a member function in this class called void add members. And that's it. That's the completion of this class. Then we are this function add members, unlike our previous example, it is not defined in an inline fashion, right? You see here we are just declaring add numbers, but later, as I said, most of our functions can be defined outside the class, and we need to use scope resolution operator. So here we are defining the function, and this is the scope resolution operator that we are using, where you have add. Again, we need to repeat whenever you are defining a member function of a class that's using template or that's declared using template. You need to repeat some of the mandatory statements, like repeat the template type name T, that statement over here. And then after that, you can have your class. Again, this is something mandatory whenever you are defining the function of the class that's using template. We have an angular bracket, and within that you have whatever data type that you're playing with. So here T represents that data type. And then we are using scope resolution operator, the function name. What this function will do is it is going to see out print results equals to first plus second, right? Because first and second are the variables that we have defined within this function. And that's it. So this is our class. We have an main function over here in the second column, where within the main function, so as you see over here, then you can use this function that you defined in a class for which you use template. So you can say that, hey, now my T represents int. And then if you pass then we are defining an object one. We are using the parameterized constructor for this object, right? Because we are passing two arguments into the object, 10 and 20. And then we are saying that, hey, for object one, which is having two arguments, 10 and 20, give me the results after running add numbers function. So add numbers function will say first as the first argument, second as the second argument. It will add both of this and return the results. So this will now print out 30, and that's an operation done over int. But because we are using template, we have that flexibility of using the same functions and the same class for multiple data types. So we can use exactly the same class and same function even for double data type, where instead of int, we say that, hey, now my capital T is double. And then in our object, we can pass double to that. And as a result, when you do object 2.add members, then it is going to print out the result of 1 plus 89, 1.89 plus 8.63. I'm not that, I think somebody would be already having an answer over here, right? If it's a class, then I would expect somebody to shout the answer. So these are some of the things. Again, to recall, function should work for multiple data type, right? That's the function templates for what we use the concept of template for. Even for classes, it's the same concept where class templates are made to use the functionality of that class across different data types. And both class template and function templates are instantiated in the same way. So even if you want to use function template, you have to follow same rules like using this template angular bracket type name T. And then for the function, you would call the function in the same way, where you would say that function name for whatever data type you are using that function at that time for, and then you would pass arguments. So there are many similarities between function template and class template. Overall, you need to be clear with this concept of template, because we will be using concept of template in the future topics when we discuss trees, graphs, and different concepts further in this class. Okay, then let's jump into the constructor. Let's officially define it. What is a constructor? Constructor, as we saw over here in this example, is a special member function to initialize an object. So here we used our object one, object two. These were our objects where we were passing some arguments, and depending on that, what constructor does that belongs to, right? The add. So it was add is a constructor, and depending on how many arguments we pass, it was using it, whichever the default constructor, parameterized constructor. Here for both the cases, we use parameterized constructor. So as if you look at this, it looks like a member function, right? Add looks like a member function, but it's a special member function with a functionality to initialize the object. Most of the classes should have a default constructor. It's just a way of programming good, because in case if you don't pass any argument, by default, what it will call is a default constructor. Constructor, there are some properties of what differentiate it from a member function. That these properties include that it always has a same name as that of the class. A good thing to observe over here for the people who are attentive and are with me, our class name was add and our constructor names were also the same. That's how you differentiate a constructor from a member function. Add numbers is a member function which need not have the same name as a constructor. If it has the same name, then it is a constructor. Constructors are automatically called when an object is declared. So as you see over here for class add, we just declared an object one and we passed an argument to that. So depending upon how many arguments we passed, corresponding constructor was automatically called. We never did this explicitly, did the steps of first equal to A and second equals to B, but still when you call this function add numbers, it knows what is first and what is second, right? Although you are passing just the arguments, you are not explicitly saying that this is first and this is second. It's doing that correlation of arguments with those names of variables within the constructor. So constructor is automatically called when an object of that class is declared. While the functions, you have to call functions explicitly. Like over here, we call this function object one dot add numbers or object two dot add numbers explicitly. And then we have an example. So for our class time 24, we can have a constructor of class time 24. The name is same. We can, and this is parameterized constructor again, because there are two parameters, and we can do similar thing as what we did in our previous example inside this. Then after looking into the constructor, another topic. We are just touching topics at a rapid speed. So keep up with the speed with me. And whenever you feel a requirement that this is something you don't get, either you can just make notes of it so that after you are done watching this module lecture, you can look back to your notes and then read about those concepts again. Or You can just pause the lecture over here, but in case if you pause, then don't forget to revisit the remaining lecture again, because otherwise you'll miss some of the important concepts later, right? So I would prefer the first one, that complete watching this whole lecture at a stretch whenever you have time, and make your notes while you're watching the things that you need to read more about. And then go back and read more about those things after you are done. And definitely read more about is something, reading something for a second time or reading it more in depth, maybe from different sources, maybe doing multiple Google search, reading something online and looking at multiple examples, but it's not reading your textbook chapters for the first time. I expect you have to do that and everybody will do that. Okay, so the next concept we are going to see is constant. And particularly, we are going to see constant member functions. If you know this concept, you know that somewhere in C++ programs, you see the word const. This word const could appear behind your different functions, and that's when we call it as constant member function. According to the characteristic of constant member function, something that it's restricted from doing. What is that? Constant member function do not, as the name says constant, it has to do with something that, right? What does it don't do? Constant member function do not change any, what it does not change. What does a class have? Data items and member functions. This is a constant member function. So what is the thing that's remaining? Data members. Data members in the object. So if we declare function as a const, if you have this keyword const behind the function, then these constant member function does not change any data members in that object. This gives these couple of statements over here gives an example of constant member function. How does it look like? It could be void write time, because you're writing it, you don't want it to be changed afterwards, changed dynamically or changed by user. And that's where you give it a const type. You can use scope resolution operator. Even with that, it remains the same. It's just that you will have, if you have a scope resolution operator, while you are saying if that function is const, then during the definition of that function using scope resolution operator, you'll have a curly bracket at the end. That's it. If you have a constructor, then you also need to, if you have a constructor, then you also need to have a destructor. We looked at the constructor over here, but we will look into the destructor soon, which is very similar concept, but using some different keywords. But for both constructor and destructors, they cannot be declared as const because of just as its property that they are special member functions to initialize an object. And it's by default, you don't need to, they are automatically called when an object is declared. And that's where you might need to change after they are called, right? You might need to do some operation within them. If you, if a member function is a const, then you cannot change any data members within that, the scope of that object. And that's the reason why it does not make sense to have your constructors as const. So constructors cannot be declared as const. If you do that, you will get some error by your compiler if it's smarter. Or your program wouldn't run, or it would give segmentation fault, or it would end up with some nonsense output. Okay, jump to a next concept, which is pass by reference. Now, this concept of pass by reference also comes hand in hand with pass by value. When you are passing for any function, when you are passing arguments, you have an option. If you can pass these arguments by value, or you can pass these arguments by reference. If you are passing it by reference, then you will be using the parameter ampersand, and for passing it by value, you don't need any parameter, and that's how you identify the difference. So here in this function, in this example over here, we are having my function, and we are passing the argument of my function x by reference. So this is how you use ampersand operator to pass by reference. Then within this function, we are giving some value to this x, and we are printing the value of x from my function is whatever. Then you have the main part of the program where you are initializing a variable x, and you are having some value which is different from within whatever it is within the function. And after declaring x and defining it with some value, then you are calling this function my function for this variable x, where x is exactly the argument that you are passing. Finally, you are doing a printout of value of x from main function is something, right? So whenever you execute this program, it's going to print out two statements. One is from within the function. Whenever this function is called, it's going to, your call stack is going to go to this point, right? And then it's going to execute whatever is there in this function. So it's going to print a value of x from my function something. And then again, your call stack is going to come back here. The next statement is this. So your second printout statement on your console will be value of x from main function is something. What do you think the output of this program will be? If you have a console open and compiler open, just type this program and look if what you expect the output to be is that the output. But first, logically, before you jump yourself into typing the program and trying to execute it to know, I want you to logically think and come up with your own suspectation that this program should print this, and then validate it with whatever you type and execute. Okay, I hope most of you have made your own expectations, and um, you should be able to compile and run this program also in any compiler. Um, so you have an answer. Here, let's see what happens, or let's understand what happens. For if we are passing anything by value, then we make a shadow copy of the counter. Or a variable. So when you pass anything by value, it can refer to two different memory address because a shadow copy is made. Visualize your memory as a long string of arrays, in which long array where you can store different items. right? If this is your memory as a long array, then, and it has different address space, like 100, 102, if it's ints, right? 100, and depending if your int is of size 2, if your int is of size 4, then 100, 104, 108, and so on and so forth. So these are your memory addresses. Now, whatever you store in this memory addresses has some name. So let's say our variable x is stored at 104 space when we declare an initialize in main function. So it stores 10 over here. But when you pass by value, it makes a shadow copy. So the shadow copy of x, when you pass it by value, that could be stored at some another memory address, let's say over here. And then inside that function, whatever you do impacts this shadow copy. So if you have passed by value, right? Are we passing by value in this function over here? Come on, everybody should have a chorus answer for this, right? No, we are not, because we are using ampersand operator. But if you would have been passing it by value, in that case, it will make a shadow copy. And whatever you do inside that function, for example, having 50 over here and then printing this value, right? Cout, that will be done at a different address. Then when your call stack comes back to the main function, your pointer comes back over here. And then when you print the thing in the main function, because you made a shadow copy of whatever you were doing within the function when you pass by value, so then it will just come and print back 10. So if you pass by value, then it would have printed 50 and 10. But because you passed by reference, now what happened here is that when you pass by reference, it does not make a shadow copy. So again, if this is your memory, what happened, your variable x in the main function, you said store 10 over here. When you pass by reference, then you didn't make a shadow copy. What you passed was its memory address, which is 104. You said, hey, there is a variable stored at 104 to the function, and this is what I'm passing to you. That's what means passing by reference. So you passed the memory address of the variable to the function. Then what function did is, okay, it took this memory address 104 and it said, okay, this memory address 104 that's labeled as X, that stores 50. So it just rewrote the thing that was stored at that address 104 as 50. And then it printed that, okay, this is what I'm storing. So this printed 50 over here. Now, when you came back to the main function, right, when your call stack came back, at this line of output of the main function, what you said is value of x from main function. When you are printing that, it's printing the value that's stored by this variable x. But because it was passed by reference, the value remains the same because no shadow copy was created. So it will again print 50. This is what happened under the hood behind the answer that you got. Now, sometimes we don't want the shadow copy to be created, right? Because logically, if it's a single variable, then why would a single variable have different values depending on if it's within the function or if it's within the main? So many times we don't want what happened when we pass by value, that thing to happen. And that's the whole reason we would use by passing by reference to ensure that such errors don't happen. Okay, so to summarize passing of variables, there are multiple options. When, in what case, if you pass a variable, a copy is made, and it will not change the real object outside the main scope. When we pass it by value, right? When we passed by value, when we saw an example of passing by value, we made a shadow copy. And the value of the real object that was stored in main over here, this was not changed. Whatever was changed was the shadow copy that we made within that function. The second case, when we do not make a copy and the real object is changed outside the main function. That's the case when we pass by reference. This is something like int a, right? When you pass something like this, pass by reference is something like int ampersand a. Well, aren't we done? No, we have third scenario too. Now, smart students should be able to answer this third scenario. We have covered the topic of this third scenario already. We touched and discussed those. In what case no copy is made and we are not allowed to change the real object outside? No copy is made, that would trigger something, right? Some word in your mind. The second keyword is you are not allowed to change. Not allowed to change should trigger another keyword. And then what I'm looking to is something that you combine with the keyword. No copy is made. The keyword that's triggered is reference. You are not allowed to change. The keyword that's triggered is constant member function, right? Intentionally, I left a space before reference. So constant reference, when you pass things by constant reference, that looks like something, you'll have a word for it to be const, you will have the const word. And this is not member function. This is a variable that you are passing as a constant reference. So the word const is before the variable and you are using pass by reference. So definitely you have int ampersand a. So if you pass something like this, where if you pass something like this, that means you are using const reference, const keyword signifies you are using constant, and then the ampersand signifies you are using passing it by reference. If you pass something using constant reference, then you are not allowed to change it outside the real object. It will give you an error and no copy is made because it's passed by reference. So in some of the programs, when you see something like this, then you know now what to expect from that variable a. Okay, so if you have any questions on this concept of classes, after reading the textbook, after doing your search and digging and all that, if you still have some particular technical questions, something like what happens if this, what happens in this case, or something like that, for which you are not able to get answer into the resources, textbook, internet, and all that, then we do have office hours every alternate week. You are most welcome to come and participate in one of those office hours. Office hours are held live, so you will have an opportunity to ask questions during office hours and we will sit together and try to find out answer for your questions. Regarding the details of when this office hours are held, you can look into Canvas homepage that will have what's the Zoom link, what's the time, what are the days, all the details about the office hours. So your questions are most welcome in office hours to talk to me. Okay, Let's continue with the concept of vector. Now, this is going to be a bit long revision class, but it's important. And I wanted to put all this together in a single link, single online lecture for you, so that you don't have to go back and forth referring to different online lectures. And if anything that you need to learn from the basic concepts of C++, this is the lecture of module 0 you need to refer to. That's why hold on and stick with me in spite of this lecture being long. And I have tried to keep it as interesting as we can by giving examples and by giving scenarios of what can go wrong in this example, giving some opportunities for you to think as we proceed. So I hope you're enjoying this. Vectors. Now, vectors is a bit of light topic, according to me. Hopefully you also feel it more light compared to the classes. Let's just revise. So how vectors are different from arrays. Now everybody knows arrays, right? Arrays are stored as a consecutive memory locations within memory locations in the memory, CPU in the computer memory. So any items, when an array is declared, you need to say the size of an array, and that's the space that's reserved for that array items to be stored. But let's say you declared something of size n, and later while you were running the program or using the program, you encountered that more than n elements need to be stored. Something you need to store m elements where m is greater than n. Then what to do? The size of the array cannot be changed during the runtime. So probably if you are using array as your data structure, then you are stuck with the constant size n. You cannot make it m during the runtime. And C++ do not allow the assignment of one array to another. Let's say, for example, if your size, so you had this, you declare a new array in that case with size m, right? Separate from your array that stores n element. Let's say you had the array A that stored n element, and now when number of elements became more than n, then because you cannot expand A dynamically, so other obvious option is, okay, then I'll go ahead and declare a new array where you said, okay, then I had an array B and I said size of B is m because now I have m elements. You can do this, but if you want the items from n, from array A to be reflected in the items of array B, because this is actually not a whole new array, right? You want to persist the items and then you want to add some more items to that. You cannot do that because in C++, you cannot assign one array to the another. So you cannot say that you will declare array B of size m, and you cannot say that B is equal to A. That's something you cannot do. And these are the two main reasons: the impossibility to expand the size of array dynamically, and the boulder or an obstruction of not able to assign one array to the another. Those are the two reasons why we have the concept of vectors in C++. So vectors, as opposed to arrays, they have some room to grow. So later, if you encounter more number of items apart from n, if initially you are storing n items from 0 to n minus 1, and then if you encounter that my number of items have grown to be total m, then you have room to grow for items that are responsible for m minus n. It provides, so with the vectors, you have different different applicable functions. So it provides a lot of complexity functions with a simple interface, right? When you want to expand the memory dynamically, then that's something complex is happening behind the curtains in the actual computer system of how it is managing memory. Because imagine when you stored n elements, there can be another program that's also using the same memory and that could assign your memory right after that n elements are done at that addresses. But if you are having vector, then you can add more elements, right? But that elements that you add cannot be now just physically using the address space that's after n, because something else is stored there. And so it's a bit complex about what exactly is happening behind the curtains, but to the user it looks like, okay, you had an array and then you have a room to grow and you can expand it. So it gives that simple interface to the users to use. The key features of vector is that you can dynamically grow and shrink. You can do both of these. And vector in a way is very similar to array, like you can address the items of the vector by using index, same as what you do in an array. And but in spite of having similar functionality with an array, vector array is a data type and vector is a container or vector is a class. And this class of vector allows you to do cool stuff like having constructors, having functions, etc. within that. This class of vector can be included by using this library include command, hash include vectors. And this class of vectors is given to you in the standard template library that's accessible to you on Canvas. Template based vector class. Now we already looked template, right? How template are useful in getting us freedom from just sticking to one particular data type. What is template based vector class? So if you're using template based vector class, you need to use some of the strict template definition requirements like template type name T. Then you have your class name, as we just looked while we were discussing classes. If you're using template-based vector class, you need to use some of the strict keywords like using T in place of wherever you indicate, wherever you want to use int, float, those type of data type. You can define it as const by using const keyword. You can define it as constant. You can declare it while as constant in your declaration statement of that class. And you need to use prototype. So while you are defining the function that uses template, then you define the prototype of that function. What is prototype? Prototype is something that can be referred for different implementations. So the prototype uses word T instead of using any specific data type like int, float. Rather than that, it would use T. So whenever you call that function prototype using any particular data type, it knows what it needs to replace is this capital T with that. So if you're calling it as int, it will replace T as int. If you're calling it with string, it will replace T as string. And then you can, as we saw, constant member function, you can also have your template-based vector class to be following const. How do we use it? So here, if you want to initialize the vector, you would say vector, use the angular bracket if it's of type int. And you would use the size. So this is your name of the vector and how many items you want to store in that vector. So that's your size, 5. If you want to store strings in the vector, again, the name of the vector, and 10 is your size. So this will allow you to store 10 strings like ABC, BCA, CAB, XYZ, so on and so forth, 10 strings. Yeah, I just accidentally, these all strings happens to be same. They doesn't have to be same. If you're storing char, if you want to initialize as well as give some initial value to each item in the vector, then you pass two arguments, where as you see over here, we have a vector of type char, and we have two arguments. So the first argument says that this vector line has, the size of that is 80, and all these 80 elements, 80 chars in this vector line are initialized to null. So it would store 80, this vector would store 80 chars, and each of them is initialized to null to begin with. If you are using something like this fourth example, where you have time 24 as your type, given that you already defined that class and you included the necessary files, then you can use it as a type, and you can have an open time vector where you are storing the time within that. This says you have 7 elements into that, and this says you are initializing the time to be 9 o'clock at the beginning. Okay, so then after we saw templates, template concept in connection with vectors, let's brush and see our concept of constructors in link with vectors. So here I'm showing you an example program, because what best way to learn from actually seeing what happens in the program, right? As I said, if you want to use vector, we need to use this header file, include vector. We have main. In main, what we are doing is, let's try to decode what each of these statement does. So the first statement, where we are declaring a vector of type int, right? Vector name is first, and that's it. So that's, we don't have any arguments. When we don't have any arguments, it would just declare the vector first, an empty vector of ints. We are not saying what size is this vector of in that case. The second statement over here, you are saying that the second vector is of size 4, and you are initializing all the 4 ints to 100. So this is going to store 100, 100, 100, 100, something like this. Here you are just initializing a vector. You are not saying the size, just initialization. So it's not going to store anything, but it's going to initialize first as a vector, and it's going to have a relation that in this first vector, in future, if you want, you can store ints in the first one. What happens in the third one? There you are using the concept of iterator. For the people who are aware of iterator, as I said, you can refer to chapter 6 of your 4 and top textbook to know more about iterator. But this is how we'll be using iterator in the light of vectors, constructors. All these concepts are used together while you are writing a C++ program. So it's very tough to, it's very important to understand the harmony of using different things when you are writing any program. That's what we are trying to nail down here. So while using iterator, you will have the pointer of your, from where your iteration would start until where your iteration would end. You can define vector by using the concept of iterators, where you would say that, hey, third is my vector, which is going to store int. and it will start from second begin, it will end at second end. So by this time, remember, when you are declaring third, you already know second, right? So you know the second. In this, it will declare a vector. You said it needs to start from second begin, so that it needs to have this value that's stored at the in the second and the first as its first value, and it needs to end at the second end. So at the end, it will store four values, each initialized to 100, same as second vector. Then the fourth statement over here will initialize fourth vector, and here we are using copy from your third vector. So when you just have one single argument, and if this argument is not a size, but rather than size, it's some another vector, that means it's going to copy. This is how you're going to use this vector class. So this means we are copying the items that's stored in third vector. Indeed, we are storing in third vector 4 ints initialized to 100. Then finally, we get down to declaring what are we doing in this statement over here. We are just declaring an array. You are declaring an array, my int, and then you are saying 4 items. You are saving 4 items in that array, 16, 2, 77, 29. But after you declare this array, in this vector fifth, what we are doing is a bit complex. What is it doing? We are using iterator constructor. So what we are trying to construct our vector from array. Like what we did, we constructed our vector from vector when we constructed third from second. We constructed a vector from vector when we constructed fourth from third. But while constructing third from second, we used a concept of iterators. While constructing fourth from third, we use the concept of copy the vector, right? Now, while constructing fifth, not from another vector, but from an array, which is my int, if we want to do that, what we need to do is pass your first argument, same as when you are constructing vector from a vector. Your first argument is from what you want to copy, right? Pass the array as your first argument, but this is an array and it's not a vector. So it does not know what is the type, or it cannot relate directly as what vector can relate to vector. In order for us to say computer how to relate to array, there is some more information we need to give. That information is about the size. So what we are saying is, okay, begin with whatever address of my ints begin with, right? Begin from here and copy the elements until my int plus size of int, which is 4 bytes, divided size of my int, which will be 16 over here, right? Size of this array, my int, will be 16, divided by size of int, which is 4. So that will give you 4. This 4 is nothing but 4 items, right? So we are saying that start with wherever is the first item of this array located. My apologies for a goods train that's passing near by me, and that's honking, and that honk is very loud. So let it pass by. Hopefully, maybe some animal is on the track or something that it's trying to honk and say that, okay, I'm coming, move, move, move. Okay, I think we are good. Oh, let it pass by. Let the honks complete. Okay, at least it went far. Let's continue. So my int, we are saying the vector fifth to begin copying items from the address of the first item of my int, and copy until what? Copy until a copy until you are done copying 4 items from that first address. So it will copy in this vector fifth. It will have 4 items that is said by this command over here, right? That's how we decided it will have 4 items. And we said that copy the items from my int. So it's going to copy 16 to 77, 29. That's your vector fifth. Finally, you are printing cout, the content of fifth R. You are having, in order to print, you are again using here the concept of iterator. So you are saying that for std vector type int, iterator it, this is how you use iterator using scope resolution operator, that is equal to fifth begin. We are starting from fifth begin, that's here, until your it, that's your iterator, right? Iterator is initially located at fifth begin, and you are going to loop until you reach, so this is your loop until command. You're going to loop until this iterator reaches the end of fifth, so that's this position. And every time, for every iteration, you're going to do plus plus it. So for the first iteration, it will enter into this for loop. It will cout whatever is there at that position. So it will cout pointer it. We'll soon look into pointers, but I assume you are at least aware of this basic minimum of pointers. We are going to print this pointer it, and then we are going to go to new line. So what it will print is 16 to 77, 29, this for loop, and that's it, then return 0. With this one program, I tried to illustrate different concept of what are different ways in which you can use vectors. Try to understand this and try to write your different versions of different program, play with this class vector. Some another functions that's provided in the class vector, apart from initializing and copying vector from another vector, or copying vector using iterator, or copying vector from another array, or these all things, we have some cool functions that we can use while we are using this class vector. These functions are very straightforward as it goes by the name. So it's like back, it will cout the last element of the vector 12. So if your vector is this, v dot back will print out 12. If your vector is again the same, then v dot size will print out the size of the vector, which is 1, 2, 3, 4, 5. Push back will add a new element. So if you do v dot push back 5, it's going to add 5 at the end. So your vector will become now this. Then again, cout v dot back will print out 5 now, because that's your last element. Your size is now 6 with the new element added. Pop back will remove the last element. So after you do pop back, 5 is removed. And after this, if you do cout v dot size, what will it print, guys and girls and everyone? What will it print? 5, because you popped the last element. After popping, your array is, if you print your array, that will have only 5 elements. Very straightforward, simple concepts. The limitation is you cannot add and delete elements from front or anywhere other than the back. Vector class allows you to do add and remove only from the back. So as you see, all the functions here are push back, pop back, and print. Print, you can print all the items of the vector using the index, but adding and removing the element can only happen at the end of the vector. Moving forward, if you want to resize, as we said, the biggest difference between array and vector is vector allows you to resize, the flexibility of increasing when you need. If you want to resize, how would you resize? So modify the size of the vector. You would do something like void resize, and you would have what's the size you want to give and what do you want in that size. If the sizes increase, the value fill is added to the element on the tail, right? As I said, that you can add and remove elements only at the back of the vector. So when you increase the size, it's implicitly understood that that additional size buffer is added at the end of the vector. And if the sizes decrease, the original value at the front are retained. So that says if the size is decreased, then you will lose the elements or the elements will be deleted from the back. Adding and deleting, everything happens only at the back of your vector. So again, some of the example over here and what happens, I think you can correlate to this example by yourself. So first we have v.size, which will print 5 over here. Then you have v.resize to 10. So we added 5 more elements at the end. We resized it, and this elements will be added at the end. They're initialized to 0. Then we said v.resize 4. So when you remove the elements are deleted from the back. So last 6 elements are deleted, only first 4 elements are kept. And if you would have done v.resize 10, 1, then it will add another 6 elements at the end and initialize them with 1. One more. Yep. Again, if you have any questions on vectors, please try to read your textbook. Please try to search online, read another materials, read another reference textbooks. And if you still have some intricate technical question, then you're most welcome to the office hours to ask your questions. Let's keep continuing. And next topic that we are going to see is overloading. Now, the concept of overloading it's defined as we want to get more out of one function, and that's when we call function overloading. So you want to use one same function and you want it to do or to be able to perform multiple tasks for you. In the same way, when we are talking about operator overloading, we want to use the same operator and we want it to be smart enough to perform multiple tasks for you depending on the context. So this diagram over here differentiates your overloading and concept of overriding. Again, if you are new to this word of overriding, please look up the definition. But that's an object-oriented concept, and these two concepts are most confused with each other. And that's where I think this diagram tries to illustrate the big difference between both, where overloading is having multiple arrows. So you have a same function, which is your bow, and you want you want your functions to perform different activities depending on context, as you have 3 different arrows over here. So you wanted to perform hit three different targets whenever you need them. But overriding is something more like combining one arrow with the other. As you see, it's tied over here. where you are not necessarily intended to perform different functions, but you are using combining the functionalities of two different arrows of the functions. So one of the example of function overloading is what's first. Let's see what's if you have overloaded functions, what remains same among them and what's different among them. So overloaded functions will have same name. That's how you say that these are overloaded functions. If they have different names, they are two different functions, right? So they have same name, and along with same name, they have same scope because they have same name. Both comes implies implied. But in order to be, if they have same name, same scope, and everything same, then it's basically the same function. So what's that part of overloading that differentiates its functionality depending on context? That part is it has different parameters or argument list. So as you see here in this class rectangle, we have function set size that is overloaded. Set size has same name. All this has same name. So that's an overloaded function. What's different among them is the parameters. So different arguments and parameters that it's passing. Number of arguments is different, and also the type of arguments is different. Like it's passing to int, it's passing to float, it's just passing one int, one float, first float and then int, a float, nothing. And that's what makes the function overloaded. What's the purpose of overloaded function? Can somebody think of that? Well, sometimes you want same function. For example, let's go back to the same example of class rectangle. If you are setting size of the rectangle can have length and breadth, right? There are two parameters, height and width. Now, height could be a float, width could be a float, both could be int. There could be variations depending upon what rectangle are you considering. Maybe your rectangle does not exist. In that case, there can be nothing. Maybe your rectangle is a square. In that case, your height is equal to breadth. But more important than that, what is this height? That would define if it's an int or a float. So in that case, if you want this something that you're doing using the class rectangle to operate over all these different variations of types of rectangles you can have, then you want to overload these functions that you are using in class rectangle, and set size is just one example of that overloaded function. So the compiler identifies different versions of the function by its unique signature. What this signature consists is, first, it has the function name in its signature, and second, it has parameter types in this signature. So with these two things, it makes its signature. Function name is same across all the overloaded functions, and parameter type is something that's different across overloaded functions. So combining these two things, we can make a unique signature for each overloaded function. So for example, for the rectangle class, the set size function that we overloaded, that can have a signature like set size, that's the function name, int. This is a unique signature. Set size int, that's a unique signature. Set size float, that's a unique signature. That's how the compiler is going to refer to that overloaded function. Changing the return type does not change the signature, as you see over here, because the signature does not contain or does not store the return type. For example, if you have a function get size int, and that function is returning int, versus if you have a function where I think there's an error where I want to show if you have a function get size int that's returning a float. Then in this case, for both of these functions, the signature will remain same in spite of one returning int and other returning float, because in signature we are not storing the return type. Now, given that if just the return type is different, is these two functions, int get size int and float get size int, is it an example of, is it an overloaded function? Is get size an overloaded function or not? Well, if you read the next line of the same slide, you should have your answer there. Overloaded function can have different return types. So different overloaded functions, like let's say, for example, set size, when it has different input arguments, it can have different return type. It does not restrict its return type. But the example of get size, if you do not, if the name is same and if your input argument is exactly same, right, then you don't store, this is the total amount of information that you store in the signature. And then the signature of overloaded function is not able to differentiate just with your return type, void int or intent float or something, that these two is an overloaded function, and that's why there will be a problem. Now, what will be this problem? Write a example code to resolve your curiosity and see what's the output that you get when you do this thing. But that being said, if you have different arguments, then overloaded function allows you to have different return types. You can have different return types in overloaded function, but does only having different return types sufficient for it to operate as an overloaded function? That's something you should figure out by writing your own program. And if you have questions, then see you in the office hours. Next, we will talk about operator overloading. That's the concept of same as function overloading, but rather than the function, now we are dealing with operators. Now, as soon as we say word operator, something that must trigger your mind is there are different types of operator that your compiler considers, such as unary operator, binary operator, ternary operator. This unary, binary, that categorization depends on how many arguments this operator take. Some operator just take one argument, unary operator, some operator takes two arguments. For example, plus, minus, you need an argument before that and you need an argument after that. That makes them binary, and so on and so forth. So when you are dealing with operator, their nature of being unary, binary, that cannot be changed. That remains the same. But still, with that being same, you can still overload this operator. For example, the operator of addition can add ints or it can concatenate string, right? For example, if we are using operator of addition for 10 plus 9, that should result 19, that's adding int. Or if I'm using the addition operator to concatenate strings, then if I have something like this plus class, then what result will it give is this class. It will concatenate two different strings together. So this then, if this addition operator is able to perform both this function, then that addition operator is an overloaded operator. The operator plus, minus, multiplication, equal to, double equal to, less than, greater than, they do different things depending on the type of parameters. So if we have a version of plus, where we pass plus by using int, it would do one thing. It will give you result as addition of two different numbers. While if you give the parameters as string, then it will perform differently. It's doing different task where it's concatenating two strings. And this is operator overloading. And when you have overloaded operators, then there are many different intricacies, intricate details that's going on, what's happening again behind the curtains, right? Like when you want to concatenate string, you need to allocate a new string that is of size of the character of the first string plus the character of the second string. Then you need to copy the character of first string into the first characters of that new string that you allocated. And after you are done with that, then you have to copy the character of the second string into the next successive space of that new allocated thing. So if you are using an overloaded operator, then you don't have to do all these things manually. So it shields you from that complexity of doing everything. There are some restrictions on what operators you can overload and what operators you cannot overload. Some of the operators that you cannot overload are the ones that are listed over here. So like for example, the scope resolution operator, your compiler would not, that's a limitation from C++. So your compiler wouldn't allow you to overload that operator. But almost apart from this list of operators, you can overload any other operator, plus, minus, multiply, divide, all those. The arity of the operator, as I said, operator being unary, binary, and so on and so forth. That arity of the operator, as we already discussed, that cannot be changed. So if you're overloading an addition operator, it should, if the arity is 2, that means it should take 2 arguments even in the overloaded scenario. If you are overloading plus plus operator, the arity of this operator is 1, right? What we do, a plus plus, b plus plus, plus plus a, plus plus y, something like that. So the arity is 1. Only one additional parameter goes with this plus plus, minus minus, all those operators. And even if you are overloading it, it will still take just one operator with it, or one variable with it. Overloading does not change also the precedence apart from arity. What is precedence? Well, the compiler has an order of performing different operations in different priority. For example, give more importance to perform addition upon division, something like that. So compiler has it set, and even when you overload the operator, that precedence cannot be changed. So if it's prioritizing addition over division operator, even while you overload the addition and division operator, it will still prioritize the overloaded addition over division. And then we cannot change how operators behave on built-in type. That would be a violation of our simple understanding, right? For example, what we are doing in this example is a violation. We are taking two terms, LHS and RHS, and we are trying to overload operator add to actually do subtract rather than add. This is something against our understanding. So then if this is allowed, what would happen is in that program, whenever you add, rather than adding, it will subtract. So that's why this is something we should not do. It's not allowed. And at least one operator must be user defined class. Otherwise, redefining the same thing is kind of useless, right? Because if you are overloading an operator, then you want to overload it with something that's user defined, something that the system is not doing it by itself. If you overload addition operator by adding to int, system would do it by itself whenever you use addition operators. So there's no point of overloading it then. If you want to do concatenation of string by using addition operator, then it makes sense to overload addition operator. So something like that. So these are the rules you need to take care whenever you are using operator overloading. Now, operator overloading with class member functions. Let's just take a very brief glimpse at this. This is a pretty complex concept depending on if you're using class member functions, if you're using friend functions. Again, if friend functions doesn't ring a bell, textbook is your best friend. So operator overloading with class member functions. There you have a new member function within the class with the left-hand operand, which must be an object. So your left-hand operand, while you are overloading a new member function, that must be an object of that operator. So the implicit, this is the operator, and then you have the parameters of that operator. LHS is used to call the overloaded function, right? As we had in the function overloading, we are using this to call our overloaded function, right? And that's where the name of the function needs to be same. In the same way, while you are using operator overloading with class member functions, right? You're overloading an operator, but you're using it with class member functions. So even in that case, your LHS is used to call the overloaded function, and your RHS is used to pass the parameters. Like over here, your RHS is used for parameters and your LHS is used to call the overloaded function. Now, depending on the scenarios of if you're using a overloaded operator with a friend function or overloaded operator with a member function, the way you call overloaded operator or define overloaded operator will be different. If you're using it with friend function, if we are overloading operator plus, then we would have to say that, okay, this is the class, this is the operator that you're overloading. And this operator has parameters such as const send and the value. So as you see, the difference of using overloaded operator with member functions, you don't have that first argument, which a friend function would have, because it's not a member function of the class itself, but it's a friend of a class, and we're using the function of that. And while returning, again, it has some extra arguments, like we need to say what the friend, this, like which class this function is friend of, sends, and the remaining arguments are same, m dot send plus value, m dot send plus value, and we are returning the sends. So you can overload function in a class, you can overload function in the friend functions, member functions, all that. You can overload operator by itself in the class or in the function. You can also overload operator while using friend function or while using member function. These are different functionalities of overloading. YouTube, I also think, is a good resource for learning about overloading, because sometimes reading the context does not make things that clear to you, but watching the context and some animated, so I put some links over here, those are like animated content, and that visual representation will allow you to understand overloading better. But if you are looking online, then be careful to look multiple sources and not just rely on single source, because there are chances of false information online too. So if we don't want your concept to be built on that. So first read the textbook. That's definitely the truthful information. In order to understand the textbook, the information that you read in the textbook better, you can use online information as your reference apart from textbook. and you can watch videos, this that. But when you do that, you got to be if there's something wrong that's presented, then you got to be able to recognize that. And that's the whole reason first rely on your textbook. Again, if you have any questions, you know the drill. Please feel free to join the office hours, get the details on Canvas about when they'll be held, the Zoom link for office hours. Our next concept is pointers. Before jumping into pointers, let's take a brief break of 5 minutes, and then we will start discussing pointers. So please feel free to refill your water or take a 5 minutes break. Okay, welcome again. Let's start with our concept of pointers. So first, in order to understand pointers, we need to look into how things are stored into the memory. So as we just said before, while discussing the concept of iterator, imagine that your memory is a long, big array of content. Everything that you are storing storing in your system is stored in this long big array in the memory. And when you store things, you usually have names to your variables, right? Like X, Y, something like that. So those names are stored
Every location in your memory has some name, but every location also has an address associated with that. So if the memory is a long big area as shown over here, it will have some specific, every memory location will have some specific address associated to that. Then depending upon what we are storing in that memory, for example, if it's an integer x, then we can store value 50, or on an other case, if it's a char a, then we can store some char in that space, in that space of memory. So each variable has a value, it has a memory location, and definitely it has a name. And these are the things we are visualizing. When assigning values to the pointer, what is the address of the integer in the memory? How would you find out the address? We already looked into this while discussing the concept of pass by value, pass by reference. If you want to look into the address of uh, any variable, then we use operator ampersand. So if you want to look into the address of where this x is stored, then what we would use is something like ampersand x. This is ampersand. I have very beautiful handwriting, so thank you for that. I was just being sarcastic. But until you understand, we are all good. So that's ampersand. Set P1 to point at actual address item. While we use pointer, we use this extric operator. That's how we say to the system that this is a pointer, and it's not just an ordinary variable. So here we are initializing pointer P1. We are taking an input or what to store at that pointer. So let's imagine our memory as this, again, a big array where you are initializing pointer P1, and then you are saying what to store in this pointer P1. Let's say the pointer P1, this is a pointer, and you are saying this is pointing to something, and whatever it's pointing to, that's being input by the user. So you take the value, let's say the user is inputting here, because it's an int, we are giving an input of 20. So then 20 will be stored here. Then we are doing this operation where we say that y is equal to 2 plus pointer p1. So whatever this pointer p1 is storing that refers to 20, we are adding 2 to that, and we are storing that in this another variable y. So in our visualization of this memory where we have this big array, y is another variable, so it will occupy a new address space in our memory. And in this y, whatever we are storing is 2 plus pointer p1. So that's 20 plus 2, 22. Then we have our fourth statement where we are doing pointer p1 is equal to pointer p1 plus 1, an operator of pointer with pointer. So we are incrementing the value that this pointer p1 is pointing to. That's this address space, where imagine again this is an address space somewhere like 101, 102. Again, depending upon the type of what we are storing, because these are ints, it will be 104, 108, so on. So whatever this pointer p1 is referring to, which is 20, we'll be adding 1 to that. This will become 21. And then finally we are printing it out. So it will print this cout pointer p1. It is going to print 21, where we see that p1 without the pointer mark is equal to address of x, or address of any variable. If x is a variable, then we say that P1 is equal to address, that is ampersand operator of X. P1 stores the address of another variable in that case. Here our X can be this. We doesn't have to name our variable while using pointer. As you see that in this piece of code, we didn't use X anywhere, but it's just for our understanding. We can or we cannot. Some you will see some code that uses variable name, and then it uses a pointer to point to that variable. You will see some code that will just use a pointer, and it will take values to whatever the address that pointer is referring to, like this piece of code over here on the left. But what you need to understand is the asterisk operator is a dereference operator, and the ampersand operator is address of operator. So using an asterisk operator, if you have something like pointer p1 is equal to in this case we had pointer p1 equals to 20. So this is same as x is equal to 20, right? But using an address of operator, this both statements are not same as address of p1 equals to 20. This is not true. Neither it is same as address of x is equal to 20. Even this is not true. You can decide what to store in the variable, but you cannot decide where to store this variable. Computer needs to find it out depending on the runtime situation by itself. So you cannot say address of this variable needs to be this. That might not be available. So that's an illogical demand. That's why pointer p1 can be used and analogous to how you use variable, and because point this asterisk is a dereference operator for that variable, but you cannot use address of operator in that case. Let's see some examples to make the usability of address of operator, dereferencing operator, and the variables more clear. So here we have an example where we have this 4 lines of code where you are initializing 2 pointers, where you are initializing 2 variables, and then you are saying that pointer p1 points to the address of x. So imagine this as a memory, and you are initializing 2 pointers, p1 and p2, and you are initializing 2 variables, x and y, and you are saying that this p1 is pointing to whatever is stored at the address of x. Imagine that this has different address space: 100, 104, 108, 112, 116, so on and so forth. So pointer p1 is pointing to, oops, not this. Pointer p1 is pointing to whatever is stored in the x, not this. Pointer p2 is pointing to whatever is stored in the y. Um, no, that's very big. I don't want that big. Okay, let's try this. Okay. Got bored of red. Let's use blue now. 108, 112, 116, something, where pointer p1 is pointing to whatever is stored at the address of x, pointer p2 is pointing to whatever is stored at the address of y. That's it. So this is what these 4 lines are saying us. Now you should say me, what would these 3 different pieces of code going to print? What will be the answer for each of these 3 sets of code? Are you ready with your answers? All done, resolve in your scratch pad? Okay, let's do it. Let's see if your answers are correct or not. So here C in pointer P1, let's say that we are taking 5 as our input. C in pointer P2, let's say we are taking 10 as our input. Do you want to reconfigure your answers depending on these two inputs so that we all stand on the same page? Let's say C in X is 5, C in Y is 10, C in X is 5, C in Y is 10. Just that the answers we get, we all in the same page. It's easy to understand. Reconfigure your answers for this scenario. Okay, I think all of you should be ready with your answers by now. So what happens in the first one? What's your output? Pointer P1 is equal to pointer P1 plus pointer P2, where we are saying that whatever this pointer P1 is pointing to is equal to pointer P1 plus pointer P2. So initially in this array, initially we'll be storing 5 and 10 when we give that C in. After that, when we do this statement, we will be storing, what we will be changing is that our first um, pointer P1 will now store 5 plus 10, that is 15. And then we are printing out X and Y. Now, X is nothing but P1 is pointing to nothing but address of X. So when you see out X, it's storing the content that's stored at that address, where address of variable X, and that's where this will print 15. And see out Y, well, we didn't touch Y and we didn't do anything with that, so it will print out 10. So if your answer is 15 and 10, well, you have got this concept of pointers under your shoulders, so that's good. For the second example, what happens? So here we are saying X is equal to X plus Y. So for the second example, again, to begin with, it starts with storing 5 and 10 as the input variables. Then this line, X is equal to X plus Y, what happens is we are storing the content that's stored at X with an addition of these two variables. So this 5 then becomes 5 plus 10, so that is 15. Then see out pointer P1. Pointer P1 is still pointing to the address of variable X, and pointer P2 is still pointing to address of variable Y. And that's why when you see out pointer P1 and pointer P2, what it's going to print is the content that's stored at that address. And that's exactly 15 and 10 in this example. So again, if your answer is 15 and 10, very good. The third example that we saw over here is we start with storing 5 and 10, same drill as what we did before. And what we are doing here is X is equal to X plus Y, same as the second example. So it's going to change the value at X from 5 to X plus Y, which is 5 plus 10, 15. But then while printing, note that we are not printing pointer P1. Here, there is no asterisk mark. We are just printing P1 and printing P2. Now remember that P1, or recall that P1 is equal to address of X and P2 is equal to address of Y, correct? So when you print P1 without an asterisk, what it's going to print is address of X. and that's not equal to 15, but rather that's equal to, depending on wherever your things are stored in memory, when you run this program your outputs could be different, but what that represents is nothing but your address, memory address location. Like in our example, address of x is nothing but 112, so it will print that, and address of y is nothing but 116, so it's going to print that. So that's address that you will get as output rather than the value of those things. So just to again refresh different concepts, if you have two pointers, if you have a variable, again, this is an example, you can say that the pointer, you can allocate the pointer to an address of something. So you can say p1 is equal to address of x, or you can say pointer p1 is equal to x. Both the statements can be used interchangeably. They mean the same thing. But you cannot say pointer p1 is equal to address of x. That means different. And think for yourself why that means different. If you understand these concepts, you should be able to identify the difference by yourself. We can, when you try to assign a value, like if we say something like this, p1 is equal to 79, that means you are trying to enforce to system to assign a specific memory location. That's illegal, right? You can say what you want to store, but you cannot say where you want to store in computer. So P1 is equal to 79 is enforcing that the address of whatever you want to store, you want it to be 79 or 76. And that's not possible. So you would get an error message, but you can do operations like P2 is equal to P1 plus 1. That will increment your memory location to whatever the P2 is pointing to, from its original memory location to whatever the P1 is pointing to plus 1 address memory location. So this is, if you do something like this, then it's not an operation on what's stored in that memory, but it's an operation on the address of those pointers. If you see out P1, it's going to print out the address. As we just saw in our previous example, if you see out pointer P1 with the dereference operator, then it's going to print out what's stored, the value at that address. And if you again see out P2, it's going to print out the address. So I recommend you to play with some of the examples like this and look for yourself how your system is behaving. There is no better learning than getting your hands dirty, right? So try, code yourself, try to change something here and there, try to make your own test cases like this, and then see how things are happening to understand it better. It's very important to understand pointers, to understand these two operators, address off and dereference operator asterisk. Both these operators are inverse of each other, as you would have seen in our examples until now. So the address of pointer P1 is nothing but address of X, because pointer P1 can be said as X, and address of X is nothing but P1, right? When you print P1 here, it prints the address. In the same way, um, pointer of address of X, where you can replace address of X as P1, which you will have pointer P1, and pointer P1 is nothing but same as X. So both this address of and dereference operator, both are inverse of each other. And this is what is one of the basic reason of confusion to many people who are not able to understand concept of pointers very well, or who mostly makes mistake while understanding the program that's given to you that uses pointers. So it's very important to understand this difference between address of operators and its use, and the dereference operator and its use. If you get that straight, you get the concept of pointers. Again, while using pointers, because Now we are using the address of operator to pass the address of whatever the pointer is pointing to. So revisiting the concept of pass by value, pass by reference is important. But this time, along with pass by value and pass by reference, we are also going to see pass by pointer, because we can also pass different variables across different functions of your program by using pointers. Here I'm showing three different examples of how you pass by value. So here variable x of this function clear, and in the main function you are just saying clear n. So you are passing it by value. You can use, definitely I assume you are aware of, you can use different names while you are passing. So in int, in your main function you can use the name as n. Within the function you can use the name as x, y, z, whatever, it's your choice. You can keep it the same or you can keep it different, doesn't matter. So here we are passing by value and then we are just printing out. Here you see we are passing by reference, it's ampersand x. When you pass by reference from the main, again, you just use the variable that you are passing. But in the function, you say that, okay, get the value of, don't get the value of this variable. So don't make a copy, but rather get the address of this variable. In the same way, when you're passing by pointers, you will say in the function that get the pointer of this variable. So that's int pointer p1. But along with saying in the function that get the pointer, because you are getting the pointer needs to point to something, right? So you cannot just say that pass get the pointer by itself. You need to say what this pointer points to. And that's the whole reason when you pass this variable from the main. So while you are calling the function clear in the main, you need to say what address. So it's ampersand n. If you are passing by pointers, it's important to say what address this pointer is pointing to. And that's why you don't have ampersand n when you pass by value, because value, we don't need address. When you're passing by value, it's going to make a new copy. Remember what we just discussed prior in the same module. When you are passing by reference, you are saying that you need the address of some variable. So you just pass that variable in the main function when you call that function. But when you are passing by reference, you are saying you need the pointer to the address. So you cannot just pass the variable, but you need to pass address of that variable in the main function. Then we have assigning values to pointers. This is important to understand about what conversions are valid and what conversions are invalid. So many people find the concept of pointers tough because when you use pointers in your programs, you get many segmentation fault because you are doing something that is not making sense to your computer. And that's what make people call that, hey, pointers are tough. But if you understand what that command that you are giving in your code is going to do in terms of how it's using the memory, that makes pointer a very easy to understand topic. So rather than memorizing, it's important to understand. Now, in this example, there is something wrong. Can you take a look at that and try to identify from the concepts that we learned? Dereference operator and the address of operator are inverse of each other. Where can we use what? Can you try to think of those concepts and try to find out error in this program? Okay, I assume this is sufficient time for you to identify the error by yourself. Let's see what's happening in this program. We are initializing the pointer int pointer p1, and then we are saying that, hey, I want to store 9 in this pointer p1. Did we do something like this before? Here we initialized pointers, then we initialized the variable, and then we said that pointer is pointing to the address of that variable. Here we initialize the pointers, and then we took the value. Then we said initialize the variable, and again we said that pointer is pointing to the address of that variable. So what bad we are doing in this, or what wrong we are doing in this example, is we are not saying to which variable this pointer points to. We are just saying that this is the pointer, right? So if this is your address space, again, imagine your memory address space. You are saying that this is pointer P1, and you are saying, I want this pointer P1 to store 9. But where, at which address? You are not saying that, right? If you say, if you define x, and then if you say that p1 is equal to address of x, and then you say pointer p1 is equal to 9, then it's a valid statement, but you are not saying that. So where this arrow mark is going to point is unknown to the program. It does not know where should it point that to. So p1 is uninitialized in this function. Now, because P1 is uninitialized, when you're trying to print the address of the value that's stored in P1, what we are trying to do is we are dereferencing a pointer that has not been initialized. And if we run this, we would get a segmentation fault because we are dereferencing a pointer that's still uninitialized. Then in this piece of code over here, we are having a variable y. We are saying variable y is equal to 5. So again, what that would do is we'll have this memory where we'll have a variable y at some address location, let's say 105, and we are storing 5 in there. We are saying cout y's value is, so it will cout 5 over here. Then we are saying int pointer yptr, so that's going to allocate this pointer yptr, and that's of type int. And we are saying that the pointer yptr is equal to address of y. Now, this is an invalid, if you run this, we see that this is an invalid conversion of int to int pointer. And why is that? Because pointer yptr is of type pointer int. Your pointer yptr is nothing but an arrow. Yptr is this. Yptr is of type int. Is of type int. Your pointer yptr is of type point is of type pointer int, and your address of y is something this, that's of type int. So what you are doing in this statement where you are saying your pointer yptr, so that's of type pointer int, you are saying that's equal to something that's of type int. That's your address of y. And that's why at this line you would get an error saying exactly some error message related to this. Rather than this, if you use yptr is equal to address of x, then because type of yptr is int, as we see over here, and type of address of x or address of y, even that's int, then this would be something that's valid to do or correct to do. Then over here, we are saying yptr equals to 9. Again, that's something we cannot do because yptr refers to the address. yptr needs to
I think my earphones are charged. Let me use them back. Just ensuring that my Zoom is connected. Okay, I know they're charged.
okay. There's that weird um, percentage of battery message. Better I just switch off my earphones. I think let's continue with just the speakers. So I think now this is the concept of difference between the dereferencing operator and the address of operator is crystal clear to you. Um, Here, if we have this statement where yptr is equal to 9, yptr is equal to address of x, and you cannot say that, dictate the address of something in your system. So again, that's a mistake. That's something that's wrong in this program. And then you are finally saying the value of this is this. So nothing wrong with the cout. Here there is an another example for you to play with. There's something even wrong with this. Identify it soon. The best way to learn pointers is by learn the mistake that are most prone to happen while you're using pointers, and that's how you would not make those mistakes. And that's why we have these examples where we are showing what could go wrong so that you don't make these mistakes when you program. This is a very experimental way of learning rather than theoretical way of learning. So what's happening here in this program is I hope you're able to find the mistake by now. We are again the same way imagining the memory. We are having a variable while executing the program from int. We are having a variable, initializing a variable n of type int, and then we are storing 10 inside that. This can, depending on your system, this can be allocated some at some different address, and then we are passing the address of n to test 1. So we are passing 100 to this function test 1, and this x will be stored at some another memory location when we pass it, because we are passing the address to that pointer, and that is storing the address of this variable n. So when you pass address of n to pointer x, x is a pointer that's storing the address of n. This is how your memory state is going to look like. And then what you are doing is see out x, that print out the address of n, right? When you see out x, this is going, the statement is going to print address of n. So nothing is come in from the point of view of compiling and running, nothing is wrong with this program. It would compile and it would run, but the output, what it would give is, it wouldn't print your value, which is mostly the intent that people want to print. You don't want to print the address until unless you are doing something with the address, right? So if you are intended to print the value, this program wouldn't print the value, but rather it would print the address, because x is equal to the address that's over here. So rather than printing 10, it would print 100 or some big number that represents the address at which this variable is stored. That's the something that's wrong with this. How about the next example? Is something There is something wrong with it. What's that thing that's wrong with this? Here we have corrected this in this, right? We are not printing x, but we are printing pointer x, and pointer x is nothing but this, right? Let's try it. Let's use orange. Pointer x is nothing but this, right? So it is going to print 10 now in our this program. So this is that mistake that we made earlier. We went back, we understood that, we corrected that, but something else went wrong in this program. That something else is, you are not passing it correctly. Not we want to pass it by pointer, right? But we are not doing it correct, because in order to correctly pass it by pointer, rather than using test2 of n, we should use test2 of ampersand n. As we discussed while we were discussing pass by pointers, pass by reference, and pass by value. Passing by pointers, it's important that you say the address to which that pointer needs to point to while you are passing. So if you just pass n rather than ampersand n, then you might get a compile time error that says, again, invalid conversion from int to pointer int, because your pointer x is of type int, and your pointer x is of type pointer int, and your n is of type int. And when you are passing this, you are doing an invalid conversion over here. We have one more example. This is last one, I swear. What's wrong with this code? Okay, I hope now this one should be quick for you guys to recognize, because we have already dealt with a couple of examples before. Here we corrected the mistake that we made in our test 2, and rather than passing just n, we are passing address of n, but the mistake that we are doing here is rather than accepting it as pointer, now we are accepting it as x. So again, this is address of n is of pointer int type and your x is of type int. So again, this is same as before, invalid conversion from int to int pointer. Okay, so now that we have understood the difference between how to pass, what things can go wrong, we have seen it in an example. Let's move on to another topic. Let's move on a bit further in the topic of pointers to pointers. Now, until now, we were discussing just the pointers, right? So we had variables, bunch of variables, and then we had bunch of pointers that points to the address of these variables. And we were discussing of how to play with this, how to pass this to different functions and things that could go wrong with variables and pointers. Now we have third level of hierarchy in this, where you have pointers to pointers. So you can have variables, you can have let's say we have variable x that can store some value 59 at address 1442, and you can have a pointer p1 that is a different occupying a different address 1693, that's pointing to this variable, to the address of variable x. And further, you can also have a pointer p2 at some another address space 2911 that points to the address of this pointer. So that points to 1693. And this is pointers to pointers. How do we deal with that? So let's imagine that we have this variable num5. Here we took 59. X does not matter. Then we have a pointer that points to the address of that. So this pointer is pointing to the address of num. Then we have a pointer to the pointer. So that's y. That's pointing to the address of x. So pointer to the pointer should point to a pointer, right? To the address of a pointer. And that's why our pointer to the pointer y is pointing to x. And we can use this thing something like, let's say we have a double, we can have pointer z. So this is again just a simple pointer example. This is pointer to the pointer is important to understand the syntax, because you'll have two dereference operator, and pointer to the pointer can only point to the address of a pointer. So x needs to be a pointer in that case. If you point it to num, right, directly, which is a variable and not a pointer, then it is not a pointer to the pointer. So in this example of P1 and P2 that we considered over here, we have things like um, x is equal to 59, int x is equal to 59. I have another goods train passing by my house. Looks like people are ordering many things these days, and there is a lot of shipments that's coming from other countries. And then these good trains need to carry all those containers from the bay after unloading the ships. Um, let's get back to the pointers. Okay. Train pass by fast. Hmm. So then we have a pointer to the pointer, which is int pointer pointer p2 in this case. and we have a pointer p1. In this case, we can say that p1 is equal to address of x. Either we can say, so in this is one another details that many people gets confused with. If I say int pointer p1, and then I can say p1 is equal to address of x, or I can consolidate these two commands in just one command saying int. So I'm declaring pointer p1, and then I'm assigning, so it's different from, this is the declaration, and from here to here p1 is equal to ampersand x, this is the assignment. So these are two different steps, we are combining these two steps in one. So doing this is valid, same as what we did over here, but doing something like this, int pointer p1, and then saying pointer p1 is equal to address of x, this is something that's incorrect. So it's a difference between consolidating two statements versus using pointer p1 is equal to address of x. This is again combining int and pointer int, that type conversion of invalid conversion of int to pointer int, that type of error over here. So we can have like this, oops, okay. And then we can have um, p2, which is double pointer or declared over here, that is equal to address of p1. This is in corresponds to the example over here. Hope this clarifies the intricate details of where people go wrong for you. Dynamic memory allocation. So this is, again, we are going through glimpse of different topic. Dynamic memory allocation. In order to do that, the goal is we want p1, we want the pointer to point to a new fresh memory in our system stack. How do you guarantee a new and fresh memory? Is by using keyword new. Because our memory stack is used and reused again and again, when you restart, the memory stack disappears because your DRAM refreshes in your computer systems. So that's why sometimes when your system is like lagging or hanging or very slow, then what you do is restart, and restart solves the problem. The actually thing behind the curtain that's happening is your memory was very heavily occupied. So whenever you are doing anything for the computer to find new space, it had to delete the older things. And that deletion took a long time. And that's where you were seeing that circle beside your cursor, while the computer is trying to find space and delete things if it cannot find space and do all those operations. But when you restart it, DRAM, your memory refreshes by itself, it resets to zero again. And because of that refresh, now when you restart and then you run the same application, the computer has all that memory that's free. And that's the reason it doesn't have to do that searching the empty space and then deleting in background those operations. And that's where restarts helps, something sometimes like a magical operation to make things go faster. Coming back to dynamic memory allocation, you want to ensure that the memory that you allocate or that you use for this pointer, it is not storing any dirty value, or it is not being used before by any program. How do you say to your compiler that you want a new set of memory from a fresh stack? By using keyword new. So how you would use that is you would declare a pointer, int pointer new, and then you would say that p1 is equal to new int, p2 is equal to new float. This two commands ensures to or guarantees to give you locations of your P1 and P2 in your memory stack such that those locations were not used before. And then you can store whatever you want in those locations and use that location same as what we saw before. So Here is an example of your dynamic memory allocation, as well as it shows the use case of a deallocation. If you are explicitly allocating your memory, if you are saying that, hey, give me something that's more important than everything else, then you are also responsible to delete that extensive thing by yourself. And that's the reason when you use a dynamic memory allocator new operator to allocate any memory, then you also need to use along with that, as like things goes in pair, you also need to use delete operator to delete or free that memory space, or let computer know that, hey, now I'm done with this, and whenever required, if you want, you can use this space to store something else. And that's how we deallocate memory. So we see in this example that we are having pointer ptr. We are dynamically allocating memory, saying that we want a fresh memory int, new int. Then we are storing 17. We are printing 17, and then we are deleting the pointer. So we are deleting the content that's stored in PTR. So imagine this again as a memory stack. You have a pointer PTR that's pointing to a new location in memory. So this location was never used before, and you are storing 17 in this new location. You are printing this 17, and then you are saying delete the item at this location. So you're deleting the 17. Okay, we deleted that. Then after that, you are again printing. After you delete it, because you deleted, it will store 0, so it will print 0. Then what you are doing is you are allocating a new memory pointer ptr2. So that's something, another pointer ptr2, again, that is pointing to previously unused memory. Now because we have already deleted, okay, because we have already deleted that, we have deallocated the memory. So computer, we said to computer that, hey, this memory space is allowed to be used again whenever you need. And now when we ask a new space to store ptr2, this space is available. So this ptr2 is going to point to that location that's available and that's deallocated by us already. So after that, what we are doing is we are storing 25 into this location. So we will store 25, and then we are printing out. Pardon me for the line misalignment. It was just the size of the screen, not enough, and that's why it's compressed. Um, but if you just copy paste this code and run with appropriate header files and brackets and everything, it will still run. So after putting 25 in PTR2 to the address where PTR2 is pointing, we are printing that. So this statement will print out 25. Then we are saying pointer PTR equals to 6, um, where pointer PTR is still the same address, memory address. So pointer PTR2 and pointer PTR is pointing to the same memory address, because we have deleted what's stored at that memory by this command delete PTR, but we have not deleted the pointer itself. The pointer, we have not nullified the pointer itself. So the pointer is still pointing there. And then we say that, okay, pointer PTR is equal to 6. So what it will do is it will clear this 25 and it will place 6 in this place. And then when you print the value of PTR2, now we are printing PTR2, not PTR1, but understand that PTR2 and PTR both is pointing to the same address, memory address. And that's why when you print PTR2, it will still print 6. So this program, your left hand side program, is going to print 17, 0, 25, and 6. Now, the only thing different that we are doing in this right side program is we are adding this new command ptr equals to null after we are done deleting that ptr. So again, what happens is initially it would print out 17, then we would delete that 17. So after we delete it, will print out 0. But we not only delete the value that's stored in that pointer, but we also nullify the pointer. So nullifying this pointer then ensures that we have no longer a PTR pointing to that memory allocation, right? So after that, when we allocate PTR2, it could allocate at the same address, and then we print out, then we store 25. We print out 25, we'll print 25. Then finally, when you say PTR is equal to 6, pointer PTR is equal to 6, we have already nullified pointer PTR. So at this stage, you will get either a segmentation fault or error that says that your dynamically allocated memory is no longer in use. So your code will break at this point and you will get an error because we no longer have access to pointer PTR. We have nullified that pointer. We can use dynamic memory allocation along with constructor. We can use dynamic class constructor where you can have a dynamic class, you can use it. So what this example is showing here is just for your reference, um, where we are using multiple concepts together now. So we are using template, we are using constructor because we are using the same name as that of function, right? The name of this constructor is same as that of class. So this is a constructor, that's how we know that. We are using the constant, we are using pass by reference, um, and we are using dynamic memory allocation, new, and we are using pointers while we are dealing with things. So yes, this is a mixture of things that a build up of a mixture of things that we are learning until now. You should be able to decode and understand this piece of code over here by yourself by now. Finally, if we have constructors, we also, if we are using dynamic class constructor, as we know that every piece of memory that's dynamically allocated needs to be deallocated, as we saw in this example of how things can mess up if we don't deallocate the things. Like the pointers could still point to something that's old and that we do not know or do not expect. So using destructor is important when you use dynamic constructor class. And how we use destructor is same by using word delete, but our destructor will have this small symbol of tilt before. So constructor, again, it follows the same rule as constructor. It needs to have the same name as that of class and as that of constructor, right? That's how we know that this is destructor for this particular constructor. The only difference that a destructor has from the constructor in the statement itself is we use this tilt command before the destructor. And inside the destructor, what we want to do is deallocate different memory that we dynamically allocated. So we would say delete the pointers and all that. So here we are having a constructor where we are dynamically allocating the memory by using new. Then we need to have a destructor where we delete the memory by using delete. Rule of thumb: in your program, if you see a word new, if when you do control F, then you need to see a word delete also. If you just see a word new and don't see a word delete, there's something wrong, and this program is going to be harmful when you run it to your system. You don't want to do that. Okay, let's summarize the concept in terms of memory allocations that we learned until now. So what blank declared object has does automatically call the constructor and automatically call destructor. How can you declare an object that would by default call the constructor, the default constructor that we declare in the class, and it will automatically also delete the space or make or let computer know that this memory space is no longer in use by this program after the program ends, and that memory space can be used by something else later. What How can we declare an object in order to make this happen? By declaring an object in a statistical fashion, in a static fashion. So if we declare an object static fashion, for example, if we declare an object like int n, or if we are using class, then something like time24 class, and we declare an object t1 of that class n. This is your static allocated object. For every statically allocated object, you don't need to call constructor, you don't need to call destructor. Computer by itself automatically calls the constructor and it automatically calls the destructor. Now, if you are using new to allocate space plus call constructor, and if you are using delete to deallocate the space and free the space that's occupied, so call destructor and deallocate space, where destructor is the one that uses tilt, then what is it called? Those are dynamically allocated memory space. So those are dynamically declared object. For example, your dynamically declared object can be something like time24, your class pointer t1 is equal to new time24. So the key to identify dynamically declared object is the keyword new. And when you have new, you need to have delete, and the destructor in which you delete the memory space occupied by pointers is identified the operator tilt. Constructor and destructor, they can allocate and deallocate dynamic data members. And in order to allocate and deallocate dynamic data members, we use keyword new and delete. That's the summary. Finally, um, let's see what is copy constructor. We have seen constructor, we have seen destructor. One another most frequently heard word that you would come across is a copy constructor. So copy constructor is used to declare and initialize an object from another object. Let's say if you have object time24 class, if you have object t1, if you want to declare and initialize um, object t2 from object t1. So object t2 is again is of class time24, and it stores whatever this object t1 is storing. So if you want to do that, you can use a copy constructor to do this operation. And so basically what we are doing by using copy constructor is same which we do below in this command by using is same what we would do when we use overload operator overloading, something like um, if we overload the operator equal to over here, no space, um, if we overload the operator equal to, then what we would do in this, what we are doing in this piece of code, two lines, is that we are having a dynamic class, we are having object A, and we are having object B that belongs to this dynamic class. But then we have overloaded operator equal to work as copy constructor, and then we are saying that object A is equal to object B. So now even the object A will store 1 comma 2, same as object A will store, sorry, 3 comma 4, because object A is equal to object B, right? So object A will store 3 comma 4, same as object B that's already storing 3 comma 4. So copy constructor is nothing but its functionality is this. So I assume with this, this would have served as a very good revision to you, giving a proper comparison of the sunlight is coming on my face. Okay. Anyways, we are done, almost done. So this module 0, I think this was a very good revision to you, serving as a refresh to the concepts that you learned, mainly the concepts that are important for C++ as a key to understand and program efficiently to be able to do the assignments and the project during the term of this course in future is classes, understanding vector containers, function and operator overloading, understanding the concept of pointers, where pointers is one of the big boulder which people don't understand, and then they are not that efficient programmer of C++ or C. Um, Understanding the concept of iterators, understanding the concept of constructors and copy constructors, destructors, dynamic memory allocation, so on and so forth, templates. So these are the things that we touched very briefly. I tried to give it more of like a review in terms of use, so that it will make you with examples so that you can identify the errors that can happen in this in these concepts. um, but definitely do read the textbook chapters and let me know if you have any further questions on any of these topics. So again, reiterating, module 0, there is a to-do list. You should be able to complete the items in our to-do list, all each and every items in our to-do list before module 1 is released. So get on to your task of this module 0. And again, Q&A, you already know what you are supposed to do. Come and see me in my office hours, right? And where did you get to know what are my office hours and how to join it? On Canvas homepage. Please refer to the Canvas homepage to get the details of Zoom link and the hours. I'll have office hours every alternate week, mostly throughout the semester, with a minor exception here and there if I have to travel for some conference or some important meetings. But other than that, all the details will be up to date on the Canvas homepage. So if I'm having an office hour, the next office hour will be updated, and then you can plan your schedule to come and make time for that office hours if you have question and answers. If you have questions to get answers to that. Okay, so then that concludes our revision and brush up of C++ module. I wish you every one of you enjoyed it, and see you back in our next module, module 1. Until then, bye bye.